please tell me what they changed 1 into. What did they change 1 into? Yeah, go ahead. Not quite. What does 1 change into? Right, Adrian? Very good. Okay. So what you're going to do here is I'm just going to save a little bit of electronic board when we do this. Why am I allowed to do what I just did? Why am I allowed to do that? Well, you're just dividing, right? You're dividing a fraction, so I'm just going to write it as that. And that's going to give us a hint of what we're going to do next. What's that?
Where did it go? To add it across.
Well, what do you mean, sir?
That, the numerator.
Yeah.
Theta.
Yeah.
I think it's the sine squared theta. Where did it go? Did it cancel?
I'll show you now. All right, Owen, what's the next step, please, on the left-hand side? What do we got with this? What do we do on the left bracket?
So it would be cos squared theta plus sine squared theta over cos squared theta.
Very good.
Oh, I thought the, that's what
Okay, divided by, I know this is divided by right now. Now, this is a big question. I'm so glad that some are after this one, because this is one we use a lot, this type of thing in our identities here. All right. Bad news, Austin. We need to get what the next step is. There are 2 potential things you can do right now. Choose either one, please, if you be so kind. No, not quite. Okay, because you can only cancel when things are factored, right? Okay, so that's not quite going to work. So I want to help them. What's one step thing we can? There's 2 things I could possibly do here right now. Someone go ahead. Oh, sorry, Quinn, you want to try? Go ahead. Yeah, good. That'll work totally. So I'll write that as cos squared theta plus sine squared theta over cos squared theta times cos squared theta over sine squared theta. Great. That looks good to me. All right. Now here's the second match. That was a good first step. Good. We have one last thing we can do to make this work. I guess there's 2 steps here again. Can somebody give me either of the 2 steps? I intentionally was mean here. I intentionally was mean. Romanowicz, go ahead.
Also the 2 cos squares.
Yeah, that'll work. No problem. Sounds good. So cos and cos. Yeah, good. So this is in the numerator, that's in the denominator, that'll go. Okay. So I'm left with cos squared theta plus sine squared theta over sine squared theta. Yeah, that works. We're so close. There's only 1 step left. Can anyone see the final step? Come on, go. Nope. Go ahead.
cos squared theta plus the sine squared theta equals 1.
Right on. And let's say, oh, Mr. Sadler, you said sine squared theta plus cos squared theta equals 1. Well, if that's true, then cos plus sine is also still equal 1. Okay, that was just me being cruel. That's where the question led to. Yeah, go ahead. Because it'll only work if things are factored. Okay, right? Like, think if I had like 2x plus 3 divided by 2, I can't just say, well, that equals x plus 3.
It would be x
Right.
plus 3.
Right? Because you have to factor, you have to cancel from both of them, right? Okay, right? So you can't just do one bracket at a time. So you can only do things once they're factored. Okay, to cancel. Alright. But yeah, so good point there by Cole, who wasn't here on Friday. Okay, that just equals to 1 over sine squared theta, which is equal to cosecant, I think. And hopefully that's what the back of the book gave us.
How the key supposed to be in terms of sine and cos stuff was.
Well, I sort of wrote that for, I wrote it in terms of sine and cos, but the textbook says cosecant or that's what that. Yes. Yeah, you could have. That's all the way through. I said, well, give me the. I said there's 2 possibilities, but no one picked this step. Right here, you could have called this 1 over cos squared theta right here, but no one said it there. You guys say, well, yeah, left, and I said, great. What we do here? There's 2 things to do, and there's a get cancel, great. Okay, but no one still said it, right? So you could have done it right at this step. That was what I was hoping someone would have said right here. 1 over cos squared theta, and then flip it into cos and cos 1 over sine, right? Put it right together. Yeah.
So if that equals cosecant squared, if you took the squares from the tan, it just equals regular cosecant?
No, you have to, no, it won't work out the same way. The reason is because the 1 will give you sine squared plus cos squared, right? And it's not, like 1 is not the same as sine plus cos, right? So it will not quite work that way. All right. But this is a very nice proof, I like that one. Okay, this is a type of identity right there. Like that was basically, this is a relatively difficult one that we did here. Okay, right? But the idea is to change things around for that, to add the common denominators. And people will always forget this part. Okay, it's like if you had like 2x plus 3 over x, I can't just say that equals 5, right? Okay, some people will try and do that, okay, but it's not, right? So, and that's basically what you're saying to do there, right? You can't just, you know what I'm saying, you gotta factor it before you cancel. All right, I'm gonna hit pause the video and then we'll start up more examples. Actually, I'll write the example on the board and you guys can try one. Let's go for, actually, a couple of things. So, a couple other topics or something. Alright, I'm gonna just, because these are hard to make up out of your head, so I think what I'm going to just do is pick one of the ones from Friday's homework. Did anyone have no problem with Friday's homework? Lovely, okay, so, and I knew that was going to happen, so what I'm going to do is I'll just pick a few questions out of Friday's homework to make sure that like this is good. Yeah, go ahead. Also, 3C and you should go to do now, because that's back, you know, like what we just did there. Alright, yeah, this would be one you guys should go and do. So this is 5A from page 310, which is sine theta over tan theta equals cosine theta. Okay, you guys can do this. Okay, you guys can do this. I'm going to pause on the video. If I were you guys, and I'm not, but I would start with the left-hand side. That's what I would start with, okay? And I'd replace sine. That's what I would do. Okay, I'm going to pause this. Replace tan, sorry, replace tan.